We're a little bit late today, but we're going to go ahead and get started just to give our speaker the full allotted time. Continue to get your food, but do so as quietly as possible as you find your seats. Um, I'm Andy Fenelon. I'm the Associate Director of the Minnesota Population Center, and a department made up our speaker today. I have a couple of ISRD related announcements before we get to our speaker. First is that applications are open for the ISRD Summer Fellowship. You can see flyers in the back on this table over here. Encourage you to apply if you're a student or have your students apply if you're not. Second, we have an awesome workshop this Friday entitled What It's Like Being an Assistant Professor. And we have four of our fantastic alumni trainees, J. Mag Carbia, Katie Berry. Yeah, those awesome folks right there, as well as Sam Gailey from Michigan State and Chris Levesque from Kenyon. Finally, you may have seen that we are going to have a very exciting event coming up in a couple weeks, the ISRD Winter Olympics, held on Wednesday, March 4th at 3 p.m. Get your teams of 3 to 5 people together, and we're going to have a competition to see who is in fact the most athletic team at ISRD. I've heard it's going to be really, really severe athleticism. All right, now on to our speaker. I'm pleased to welcome my colleague, Horacio Duarte, who is an assistant professor in epidemiology and community health here at the University of Minnesota Twin Cities. He is a physician scientist with clinical training in pediatric infectious diseases and research training in epidemiology, decision analysis, and health economics. And his research focuses on evaluating cost effectiveness of potential HIV treatment and prevention policies for adults and children in resource-limited settings. He received his MD from Stanford School of Medicine and UT Houston from UT Houston, excuse me, and did his residency at the University of Washington in Seattle. And before he gives his presentation, I'd like to present the mug in which you can only receive for speaking here in this this seminar series. Thank you. Yeah, thank you very much. All right, thank you, Dr. Fenelon, for the kind introduction. So the title of the talk today is Preventing Vertical Transmission of HIV, Insights from Simulation Modeling. So I have no conflicts of interest to declare. And so today I'm happy to share with you work that my research team and I are doing using simulation modeling to develop strategies for achieving elimination of mother-to-child transmission of HIV. So when you look in policy reports, the acronym EMTCT is what you'll see get used for this. And throughout the talk, I'll be using the term vertical transmission to refer to mother-to-child transmission. And we're very grateful to NICHD for this nice funding mechanism supporting this work, this DP1 Catalyst Award. So we'll start with some broad background on vertical transmission of HIV. I'll give you an overview of the work that we have planned, and then we'll get into details of some of the analyses that we've done so far. So a good place to start is understanding these two distinct periods when infants are at risk of acquiring HIV from their mothers. So the first is called the peripartum period. So this includes the last few weeks of pregnancy in utero, as well as, of course, the labor and delivery process. So ideally, anyone living with HIV should start on treatment right away. I'll refer to this as antiretroviral therapy or ART. But if the mother is not on ART, then the risk of peripartum transmission is about 1 in 3, so about 33% chance. Then moving on to the postpartum period, through breastfeeding, over the course of, let's say, 18 months, there's an additional 9% probability of transmission. Now, thankfully, with treatment, studies have consistently shown that this risk is significantly decreased. And if the mother is able to achieve what we call viral suppression, meaning the virus is at very low levels and is sustained over time, then that risk approaches 0. But one thing to be aware of is, so most vertical transmission globally happens in low and middle income countries, mostly throughout Africa.
And there are many differences compared to the US, but one very big one for this is that the baseline rates of infant mortality are quite high, mostly from a variety of infectious diseases. And so, although breastfeeding does carry this risk of vertical transmission, it also provides really important antibodies to the baby that significantly decreases the risk of death from a variety of other things to the baby. So many years ago, infants or experts weighed the risks and benefits of breastfeeding and determined that it's best to recommend breastfeeding for this reason. But this does present the challenge that you have to work very hard, programs and mothers, to achieve and maintain viral suppression over quite a long period of time. So thankfully, over the last 2 decades, this is data from UNAIDS, we've made a lot of progress in decreasing vertical transmission. So in the early 2000s is when ART first became available in Africa. And at the time, there were about 500,000 babies that acquired HIV every year globally. Since then, the percentage of mothers who access ART has grown a lot. So now it's about 84% globally. And we've decreased infants acquiring HIV to about 120,000 per year throughout the world. So this is the title of our grant. So informing optimal investments along the preconception to postpartum EMTCT continuum. So this continuum shown here refers to the fact that there are a lot of steps along the way that where there are gaps that contribute overall to vertical transmission. So what that means is that there's also a lot of opportunities to intervene. And so through simulation that I'll show you, we're evaluating these 6 broad categories of interventions. And I've divided them up here into 3 upstream and 3 downstream interventions. I'll make a few comments on the upstream end. So in an ideal world, we would do as much primary maternal prevention as we can. So if we can prevent mothers to be or expecting mothers from acquiring HIV in the first place, then that's going to do wonders for preventing vertical transmission. Next, as I mentioned, we've vastly increased ART coverage to 84%, but we still have to continue to get close to 100%. So although most mothers are on ART, the mathematical reality is that the risk when you're not on treatment is so high that this group still makes up for 73% of all the infections that are happening. So that's just something that we can never stop working on. But even if we address all of these upstream issues, there are also important downstream interventions that haven't been looked at quite as closely. And so among all the infants every year that acquire HIV, 18%, the situation is such that mom did start treatment, but then somewhere along the way was lost to follow-up or had what we call ART interruption. So the risk goes up quite a lot. And there's another 8% where the mom got on treatment, remained on treatment, but presumably was not able to get the viral load low enough so that there was still this big risk of transmission. So far, the areas where we've made the most progress in our analyses are in these downstream interventions. So that's what I'll be sharing with you today. And our goal is to look at all of these things in a range of different countries. And so far, we've focused on Kenya. So everything I'll show you today is in Kenya. So for the rest of the talk, I'll spend a few minutes talking about simulation. Why do we use it and what is it? And then we'll dive into the results of these various analyses that we've done. So why do we use simulation? So these methods are really helpful when you imagine this real life empirical study that you wish you could do, but you can't do it because it's either very difficult or sometimes impossible. One common reason is the sample size you need is too large to be feasible. So vertical transmission still happens a lot more than we would like it to happen, but now that we have ART pretty widely available, it's a relatively uncommon event. So when you go out in PubMed or search for studies on this, when you look at maternal HIV intervention studies, very few are powered to look at vertical transmission. So most of them will report on intermediate outcomes like maternal rates of retention and care or viral suppression. Another common problem is perhaps the question you're asking requires a really long time horizon. So if your question is how long is it going to take us to eliminate vertical transmission, that's on the order of years. And if you're trying to inform policy decisions now, that's not going to be very practical. And then sometimes there are ethical concerns. So you might want to know, what is the impact of intervention X? And if intervention X is already part of the standard of care, then it's not going to be ethical to withhold that in a randomized trial per se. So this is just one tool of others that you can use. So that's why we use it. What is it? So this involves a lot of computer programming. We happen to use something called MATLAB, which is common in the world of engineering or applied math, but you can use R or Python or whatever language of choice you have. And so we use it to develop a very complex computer-based simulation model to simulate the real life that we otherwise wish we could observe in real life. But right away, it's important to know that what we're not doing is we don't have this data set that we're analyzing, because the whole premise of this is that we don't have that data set that we wish we could have. So we have to simulate it. And then as far as the type of model that we develop, the technical term for it is a microsimulation. So all that means is that when we represent people, we represent them as distinct individuals. And to each one, we assign a long list of individual level attributes that we care about. And then, so the simulation is going to move forward in monthly time cycles. So every month, the model reevaluates the values for these attributes. And I'll briefly describe kind of two big picture things that we have to simulate. So the first is what happens to people with HIV that don't have treatment. So that's the natural history of HIV. So briefly, their immune system is going to get weaker. So the marker that we look at is their CD4 cell count. So that's going to come down. And then that in turn is going to increase their monthly risk of death from HIV. And then when they go on treatment, their CD4 count will come up, it'll recover, they start to feel better, and their risk of death goes down. So let's hone in a little bit on these monthly time cycles, because this is really important. And so for every month, for each person in the model, the model is going to ask the same question over and over again. Does this event happen? Does this event happen? So I've just shown you a sample of many of the events that we track. So for example, first, it wants to know, is this person going to die or survive this month? So the person can die of HIV, they can die of maternal mortality, or just general other causes, background mortality. Then it wants to know, is this person going to start treatment? Or if they're already on treatment, are they going to stay on treatment? Is the treatment working? And so on and so forth. So every time it asks this question, the computer generates a random number between 0 and 1, and it compares that number to the probability of that event happening. If the random number is less than that probability, then the event happens. So you can imagine this is like flipping a coin over and over again. We make sure that the simulation is large enough that you get stable outcomes. So you may be wondering, where do these probabilities come from? So first of all, these are a type of model parameters. So we have a bunch of inputs, model parameters, and we're simulating this whole huge system of events. So you can imagine that we need data from a very wide range of studies that come from lots of scientists. There's no way one single person can get all of these things. And so most of this aggregate data are from published studies that we find just on PubMed. Sometimes we'll have to use some kind of policy report from the Ministry of Health. And oftentimes we're very fortunate in that a particular parameter will have, say, 10 studies that looked at this thing. So then we have to very carefully read all 10 studies, understand them, and synthesize it and come up with what we think is a reasonable, what we call a base case estimate, and then also the range of values that we want to explore. I'll briefly talk about one very important parameter, which is the vertical transmission risk. I showed you a little bit at the beginning if you're not on treatment. So the simulation will be moving along, simulating the mothers, and then things get interesting at birth and then breastfeeding, because every month from that point on, the baby's born, and then there's a risk of transmission. So this risk, the computer looks up what the risk is, stratified by a few things. So first is the mom on ART, yes or no? If so, what was the timing of ART initiation relative to the start of pregnancy? And what's the viral load? So very low viral load has very low risk. High viral load has very high risk. Yeah, so typically that's like a big thing. There's multiple. It's a combination of regimens. So in this case, it's a three-drug oral regimen with a drug called dolutegravir as the core, and then there's a backbone of two other drugs. Yeah, yeah. Okay, so that's simulation, and now I'll share with you various results. So we'll start with part one of the viral load monitoring cascade. Then we'll talk about mentor mother programs, and then come back to part two of the viral load monitoring cascade. So first, it's important to know viral load monitoring is um, an essential routine part of the clinical management of HIV. So if you look at the clinical guidelines, they'll tell you how often you're supposed to do a viral load test for someone that's on treatment. And what that involves is taking a sample of blood, and then you're going to quantify how much virus is there. If the treatment's working, ideally the viral load level is very low, and we call that viral suppression, like below some established threshold. The goal here is you want to identify people who are not suppressed so that you can intervene and achieve resuppression. And there's two main ways that we do that. So first, you're going to do what we call enhanced adherence counseling. So again, this is a medication you're taking every day. So sometimes people just need reminders to make sure you take the medication every day. For about half of these people, that will do the trick. You'll achieve resuppression. The viral load will go down. For those for whom this doesn't work, guidelines will typically recommend switching to a different treatment regimen, what we call a second line ART regimen. There's a little bit of nuance and complexity to this, and we'll come back to that in a little bit. So then it's important to understand some of the historical context behind viral load monitoring during pregnancy and breastfeeding. So in 2017, Meyer et al. Published a really nice review paper in PLOS Med. They called attention to the fact that this is a really important population because you're also dealing with the risk of vertical transmission. And they pointed out that we just have regular adult guidelines. There's no special guidance for this population. And the time intervals in between testing are pretty long. So for example, in Kenya, you'll do a viral load test 3 months after starting treatment. If everything looks good, you'll do another one 9 months later. If that looks good, another 12 months. So these are long periods of time where if the mother is unsuppressed, there's a high risk of vertical transmission, and ideally you catch that sooner rather than later. So a few years later, WHO updated the recommendations to say that countries should tweak their guidelines so that in this population, you're testing more frequently. So Kenya happened to update their guidelines in 2022, and they said, okay, in this time period, we're going to test every 6 months until breastfeeding is complete. It was around that time that I was developing this model that I'm telling you about to look at vertical transmission. Previously, I had a full population level model to look at Kenyan adults and transmission through sexual contact. So I took a piece of that model and then added more bells and whistles to look at vertical transmission. And so I was on the lookout for interesting policy questions to address, and so what caught my attention was that this change was made without really knowing what the impact of this intervention was on vertical transmission. So a couple of things came to mind. The first is if we're going to do more frequent testing, it would be good to know how much reduction in vertical transmission we're getting compared to if we continued with the old way. But then an even more basic question came to mind, which is that for many years it had been well documented that when a viral load test is indicated, a very high proportion of the time, that test just doesn't even happen. So we ended up tackling this question first, looking at different levels of the healthcare system adherence to the guidelines. And I'll share with you a manuscript that we published last year in AIDS. And then we'll circle back to an analysis that we're working on right now, comparing different frequencies of testing. Yes. Yeah. So we we thought that 18 months was a relatively good amount of time, but we also look at sensitivity analyses where we look at as low as 12 to as high as 24. Yeah. So this is the paper that we published last year in AIDS, focused on Kenya. So we took the model that we developed and we simulated 3 levels of adherence to these maternal guidelines. So in strategy 1, we said, okay, we know these guidelines exist, but this is a situation where testing is just not being done. Strategy 2, we said that every time a viral load test is indicated, there's a 50% chance that it actually happens. And in number 3, we assume perfect 100% adherence to the guidelines. So then with these simulations, you get a bunch of different outcomes, and the key ones will focus on our maternal rates of viral suppression and vertical transmission. And we did this separately in 2 key maternal populations. So the first we refer to as the newly positive group. So these are mothers who recently acquired HIV, become pregnant, go to antenatal care, discover their diagnosis, and that's when they start treatment. And in the known positive group are those who they had already known they had HIV, started treatment, then became pregnant, go to antenatal care, and then continue their treatment. And in Kenya, at least, it's well documented that there's at least one key difference, which also likely applies to many other countries, which is that when you look at the risk of being lost to follow-up from care during antenatal and postnatal care, this risk is much higher in the newly positive group, so about 23% versus 8%. And the theory behind why this is likely the case is that in the newly positive group, you're navigating 2 big life events at the same time. So 1, you found out you're pregnant, and 2, you're also finding out that you have this life-altering diagnosis. So this is just a 30,000-foot view of the timeline that we set up for these 2 cohorts. So for both, the simulation follows them from the time they acquired HIV until 18 months of breastfeeding being completed. And then we timed it so that HIV acquisition and ART initiation happen at the same time, but we staggered the start of pregnancy so that conception happens 11 months earlier in the newly positive versus the known positive group. No, so they are simulated people that are meant to reflect reality from real data, but they're not. It's not like there's Susie in a data set and then we're representing Susie. Yeah. Yeah, so that's what I mentioned at the beginning, is that there's no data set. So it's aggregate level data from the published studies that go into the model parameters. Yeah. It is agnostic to that. Yeah, yeah. And then I've left plenty of time for questions. And then I don't know if the Zoom people can hear, but we're going to use the microphone at the end, or okay, I'll leave plenty of time for questions. Okay, so there's one important assumption that we made here. So I talked earlier about how if you don't achieve resuppression with adherence counseling, that the guidelines say to switch. Now, if you're not familiar with HIV, please take my word for it. Prior to the availability of dolutegravir, this guideline actually made sense and led to better outcomes. But there's been a big development for which now it doesn't really make a lot of sense, but the guidelines continue to say to do this. So there's this new type of therapy called dolutegravir-based ART that became available in generic form several years ago now. You achieve really high rates of viral suppression, and it's very difficult to develop drug resistance. So what that means is if you have persistently unsuppressed viral load, it's almost always due to poor adherence. So if you're someone who's unsuppressed because you have difficulty taking the medication orally every day, which is very difficult to do, switching to another oral regimen is probably not going to help you very much. So that was the reason for this assumption. And this is something that we'll revisit in the last analysis when we look at injectable long-acting ART. Okay, so here are our results. So First, we're looking at, over time, the proportion of these mothers who have viral suppression below 1,000 copies per milliliter. And the top three lines are in orange is the known positive group. The bottom three lines in green are the newly positive group. For each group, the solid line is the no testing, and then the other dotted lines are the different levels of viral load testing. So the first thing you might notice is that viral suppression declines for both groups over time. It happens more rapidly for the newly positive group, and that's largely because we established that this group has a higher risk of ART interruption. So more of them are just going off treatment and your viral load goes straight up. The next thing to look at is if we compare the difference in viral suppression between no testing compared to perfect testing, you'll see that the improvement is much more marked for the known positive group. We'll talk about why that is in a second, but that's going to translate into more vertical transmission reduction. So in this figure, at the top, the NP is the newly positive, the bottom KP is the known positive. On the left, we have peripartum percent reduction, then postpartum, and then in the red box is the total. So we're going to focus on total. And this is percent reduction compared to no testing. For now, I'll just focus on the 100% versus no testing. So the first key finding is that this vertical transmission reduction is much higher for the known positive group. So 4.3% compared to 2.7%. The second key finding for me is that even amongst HIV clinicians, many of them are surprised. Well, first, they're surprised that the impact in newly positive is so tiny. But there's also some surprise about how modest the impact is for the known positive group, and we'll explain why. So it's important to understand who it is that's benefiting from the intervention. So there's two kind of prerequisites. The first is that you have to be on ART, because if you're off ART, the intervention doesn't even happen to you. Number two is it only helps you if you're unsuppressed while on ART. So what this figure shows is over time, we're showing some key maternal events from conception to the end of breastfeeding. Each time point has a bar for the newly positive group and a bar for the known positive group. The total height of the bar tells you what proportion are unsuppressed. So that's higher for the newly positive group. We saw that in the earlier figure. The orange bar tells you what proportion are unsuppressed while on ART. And you can see that that is consistently larger for the known positive group. So what that's telling you is a higher proportion of that population stands to benefit from the intervention. So it's not surprising that they benefited more. The other thing has to do with timing of the testing relative to birth. So for the known positive group, the way the guidelines are set up and when you're supposed to test, and also the timing of delivery and the first antenatal care visit, it just so happens that there's enough time for it to reduce peripartum transmission, and it does so quite nicely. For the newly positive group, it doesn't happen early enough. So there's zero peripartum transmission. And in retrospect, that's something that ends up being obvious, but this is something that comes to a surprise to most people in the field. Okay, so that was the first one where we look at different levels of adherence. So now I'll share with you some kind of hot off the press stuff from this manuscript that we're working on. So here we're looking at the impact of more frequent testing. And since the first paper that we published, there's been some more better data where we can make a reasonable assumption that there's 70% adherence to viral load monitoring broadly throughout Kenya. And so we did this to simulate three strategies. In the first, we say, okay, we have maternal guidelines, but let's pretend like we never switched from the regular adult guidelines. The second one, we're doing the current maternal guidelines, testing every 6 months. And in the third, we said, what if we did even more frequent testing? So there's a handful of other countries in Africa that test every 3 months. So that's what number 3 is. So these numbers show you percent reduction in vertical transmission. And I'll walk you through this. So the first row, we're comparing the benefit we're getting of the current guidelines compared to if we had never changed from the old guidelines. So we have the small 0.3%, 2.8% improvement in these two groups. And then if we went even further to do every 3-month testing compared to what we're doing now, you get a 1% and a 3.3% improvement. So again, pretty modest. And that comes back to the fact that relative to the whole, the size of the group that's benefiting is pretty small. The other thing at play here is that even if you achieve the goal for a mom of finding out they're unsuppressed and achieving resuppression, by the time that happens, for a good portion of these mothers, vertical transmission happens before you reach the goal. So taking these two things together, I think some of the big picture take home point is that it's tempting to say, let's do more frequent. But the first step is really to prioritize adherence to the guidelines. So the there's very poor data in general. Most programs probably don't even know what their adherence levels are. So that's the first place to start. For example, if you're at 40%, roughly based on the things we're seeing, if you can get that up to 70 or 80, that's probably going to do as much, if not more, than revamping your guidelines to say, let's test more often. Okay, so far we've seen that these strategies have been skewed towards helping the known positive group. So you might be wondering, what can we do for the newly positive group? So that brings us to mentor mother programs. So this is a paper we published in Open Forum Infectious Diseases last year, again in Kenya. So mentor mothers are one form of many different types of retention support programs that exist for HIV. And in this case, they're peer supporters. So that means that typically there are other women, other mothers living with HIV who have had a good engagement in care. And their role is to provide adherence counseling and retention support services to their peers. So to do this simulation, we found everything we could find on studies looking at mentor mother programs. So we found 6 published studies in 5 different countries. And none of them were really powered to look at differences in vertical transmission. So they all looked at these intermediate outcomes. And there were a variety of differences, but the most consistent finding was that the evidence suggests that this is an effective way to decrease ART interruption or loss to follow-up. So when we set out to figure out how we wanted to represent the intervention in the model, we focused on its impact on reducing this risk of ART interruption. And we chose to try to approach this broadly rather than focusing on the results from one specific study. So when we looked at the range of effect sizes, it ranged quite widely. So some studies were as low as 20% reduction, some as high as 60% reduction in ART interruption. So for our main base case analysis, we chose this midpoint to say, let's assume that you get this 40% reduction in ART interruption, but we explored this range of values here. So this is how we ended up implementing. So we again looked at 2 strategies. The first was what we call the standard of care with no mentor mother program. And these ART interruption risks are the same ones that I showed you before, with the risk being much higher for the newly positive group. Then we did a strategy where you had mentor mothers, and it reduced these risks by 40%. And so here are our results in the relative reduction in vertical transmission. So in the newly positive group, mentor mother led to a 15% reduction as compared to only a 6% reduction. And just as a reminder, these are our results for the viral load monitoring. So in terms of which group is benefiting more from what, these are flipped. So this is one example of how oftentimes different groups have different needs, and you can't always do a one-size-fits-all approach. So far in the literature in vertical transmission, these are the first papers that have really looked at different subgroups of maternal populations, as opposed to just kind of lumping them all together. So every time we do any of these analyses, we do many sensitivity analyses where we explore how the uncertainty in the model parameters impacts the outcomes that we care about. So we don't have time to go through all of it, but I'll show you just one example. So if we assume that mentor mother reduced ART interruption by 60% instead of only 40%, then you could get a 22% reduction instead of a 15% reduction in vertical transmission. And so usually these sensitivity analyses are the most interesting parts of these analyses where you gain a lot of insights. And one thing that we learned from here is that there's still room for implementation scientists out there to collect more data on the effectiveness of this intervention. You saw that the The uncertainty in this parameter was pretty wide, and so this can help us update our projection estimates. The other thing is there are many reasons why it's good for programs to know what their ART interruption rates are. A lot of programs probably don't have that data, but in this particular case, if your program has really high rates of ART interruption, then that might make you decide to prioritize retention support of some form more than other things. Okay, so that brings us to the last set of analyses. So this is what I'm calling part 2 of the viral load monitoring cascade. And we're going to come back to this question of switching regimens and look at the potential role of something called injectable long-acting ART as the second line regimen that you switch to. So let me recap some of what I said before. So the first line regimen is this thing called dolutegravir-based ART. It's really great. You have high viral suppression, which is good. You have low rates of drug resistance, which is also good. But it becomes confusing when you have virologic failure and the guidelines tell you to switch, but the oral regimen you're supposed to switch to isn't going to logically help you. And that's where this becomes very nice. So injectable long-acting ART is designed to be injected every 4 weeks or every 8 weeks. So you no longer have to remember to take the medication every day. So it can help address these adherence challenges. Over the last few years, there's been some really nice data emerging mostly from the US, but other high-income settings using injectable cabotegravir rilpivirine. So these are 2 different agents from 2 different drug classes that are given as an injection. And we did a very thorough review of all the literature. And conservatively, we assumed that if you're unsuppressed and you switch to this regimen, 80% of people are going to achieve and maintain viral suppression over the course of a year. So what I'm going to show you, this is something we recently submitted and is currently under review. So we simulated, again, 2 strategies. One, standard of care, where you don't have LA-ART as an option. And number 2, where if you have virologic failure, you're supposed to switch to LA-ART. We accounted for the imperfections of the viral load monitoring cascade. So again, 70% adherence to testing. And we assumed that if you become eligible to switch, that there's only a 50% probability that that happens. So this is extrapolating from a lot of great data from the pre-dolutegravir era, where in the old days, if you're not familiar with HIV, this will just be mumbo jumbo, but you used to switch from an efavirenz-based regimen to another oral protease inhibitor-based therapy, and that used to help. But even when that was supposed to happen, it only happened about 50% of the time for a variety of healthcare system glitches. Okay, so let me walk you through these vertical transmission reduction results. So we looked at this. This is in the LA-ART strategy compared to standard of care in the 2 groups. The top line is the main analysis, the base case, and then these other analyses are various scenarios where the assumptions ended up leading to more optimistic results. So in the base case, in the NP group, you got only a 1.2% reduction. In the KP group, you got a 4.2% reduction. So again, pretty modest. And again, it's important to understand that the group that's benefiting is a relatively small subgroup. So first you have to become unsuppressed, and dolutegravir is very good, so that group is small. And then you have to not be among the 50% or more that resuppress. And so this is a great intervention for the people who need it, but that's a relatively small group. The next thing is that when you look at mothers who successfully switched regimens, and then we look under the hood from the time that they become, and this is something you can do only in a model because the model is all knowing, but you can't do this in real life unless you're testing like every day. From the time that you're unsuppressed to the time you switch, on average, it took 9 months. And this is simply a reflection of the fact that you test every 6 months, and then you need an unsuppressed test and a repeat test, and you have turnaround time for each test, 3 months of adherence. So it all quickly adds up to 9 months. We also counted for the imperfect cascade. So the scenario that had the most optimistic results was when we said, what if we had perfect testing, and when you were supposed to switch, you always switch? So in the KP group, this increased the impact up to close to 10%. So here's some take-home points from this one. The first is that, again, we see this modest impact, but it's important to know because injectable, this is a really promising new technology. And I don't want people to think that this technology is bad because the technology is fantastic. The thing is, this is not a problem intrinsic to LA art. It's that we're using it as a second line regimen. And in the pre-dolutegravir era, no one had ever evaluated the impact of a second line regimen. So this is really more a reflection of an effective second line regimen. The second thing is that um, if we're trying to achieve this big goal of elimination, a very common thing that happens is there's always some new technology in the pipeline, and people put a lot of eggs in that basket. And so it's important to know ahead of time that that thing isn't necessarily going to solve all of the problems. We still need to continue to use all of the tools in the toolbox. And the third is this adds to the list of reasons why we should strengthen the care cascade. So that by itself is going to help a lot of things, but we see here that that's going to set this thing up for success. And overall take-home messages, again, is that the nuances of different subgroups really are going to end up mattering. So that's something that we need to take into account in the big strategy. Number two, there's multiple gaps. So we need lots of different interventions, even those with these modest impacts. And so this is just the first steps in chipping away at the work that needs to be done, which is that you can't have a logical, comprehensive strategy if you don't know the numbers. So you need to know what the impact is of these interventions. And there's just a lot of gaps out in the literature in terms of knowing what the impact is. There's still a lot more work to be done. So we still need to do more work on the downstream. We're also going to be looking at these upstream interventions I shared earlier. So far, I've just shown you the impact on vertical transmission, but we're also going to be looking at their cost effectiveness. So resources are very limited in these settings, and so you need to use all of your budget in the most efficient way possible. Ultimately, our goal is to try to figure out what the optimal combination of these things is. And for now, we focus on Kenya, but we're going to be looking at other settings as well. And so I just want to thank, we're very grateful to our funders, NIH. There was a very nice Spark grant from MPC that contributed to this, so thank you. Pharma Foundation. And I've been very lucky to work with a lot of great people, some really great trainees, collaborators, both here at the University of Minnesota and outside. And I want to extend a very special thank you to my research scientist, Dr. Jeanette Birnbaum. It's been a great pleasure working with her over the last 4 years. And I'm very proud of the work that we've been able to do together. So yeah, thank you for inviting me here, and I look forward to your questions.